Over the years, I've played around with quite a wide range of antenna matching units, particularly the MFJ range. Well, around about a year ago or so, the MFJ factory closed down, so it left a bit of a vacuum. But I've been having a look at the Comet range of antenna matching units, in particular the CAT-300. It resembles the MFJ range of antenna matching units, but it's a bit different. So let me take you through this rather interesting matching unit. It may well be something that would fit into your station. The Comet CAT-300 handles power levels up to 300 watts, and it covers all the HF amateur bands from 160 meters to 10 meters, and in addition the 50 megahertz ham radio band. Although it's got a maximum power level of 300 watts and a maximum reading of 300 watts on the power meter, you can also switch to a lower level of 30 watts. So if you're running low power, then all the readings relate to 30 watts rather than 300 watts. It uses the traditional T-match network, which involves two capacitors and one switch inductor, and the switched inductor, which is on the centre of the panel, is designated to the various bands. So unlike the MFJ one, which went from A, B, C, D, E, F, G, on this particular model they actually show the bands. And if you look carefully, you'll notice that on the 160 meter band there are two segments covering the 160 meter band, and also on the 80 meter band there's two segments, because on those bands they require quite a large inductance range. The main meter reading on the front is a cross needle meter reading, and I'll show a demonstration of how that works a bit later in this video. The bottom three buttons add versatility to the unit. On the left hand side you've got switch between average and PEP power readings. Then you've got a switch which actually bypasses the whole unit. All you're reading is the VSWR readings. And on the right hand side you've got an antenna switch, because there are two antenna sockets on the back, so you can switch between antenna 1 and antenna 2. And even when the unit is bypassed with that centre bypass switch, you still have the ability to switch between antennas 1 and antenna 2, so it makes the unit quite versatile. If we look at the rear, you've got on the left two antenna sockets, antenna 1 and antenna 2, and below that you've got a red terminal. Now the red terminal is for an end-fed wire, and I think that the end-fed wire terminal is actually wired in parallel with antenna 2. And this means to say you've either got to have a coax line into antenna 2 or an end-fed single wire into the red terminal. And on the right hand side you've got the input to the ATU from your transceiver. You've also got on the bottom right an earth terminal, and of course that earth terminal would need to have some sort of counterpoise wire if you're using an end-fed wire into the red terminal on the left hand side. And then top right you've got a DC socket which permits you to feed 12 volts DC into the antenna matching unit simply to illuminate the meter. The overall finish is very good indeed. It's a nicely fitted cabinet, no rough edges, and just altogether it's a very well made unit. I removed the top cover to have a look inside, and again it's very well laid out. On the left hand side at the rear you can see the through line sensor, which is a fully enclosed through line design. And then if you look at the front, the capacitors are quite wide spaced actually, so they look more than enough for the power involved. And then you'll see that the actual inductor is in two sections. On the left hand side you've got a vertical inductor which looks to be for the lower frequency bands, because it's obviously a larger coil. and then to the right is another inductor which is used for the higher frequencies. And interestingly enough, the two inductors are at right angles to each other, so there's no coupling between them. I know from the my previous experience of antenna tuners, you can get self-resonances in the inductors, but I think they've positioned these two inductors so that there's no risk of self-resonance. One thing I should mention is balanced feeder. How do you cope with balanced feeder on this matching unit? Because some of the MFJ units had balanced feeder outputs. Well, the MFJ item simply had a Balun inside, a 4:1 Balun inside the cabinet. So if you want to match balanced feeder with this antenna tuner or matcher, all you need to do is to get a short length of coax cable, about a metre or half a metre long, connect it to a 4:1 Balun, and then connect your balanced feeder to that. That's the way to deal with balanced line. It works very well. Now let me show you how the cross needle VSWR power meter works. I did a review very recently of the Daiwa VSWR meter, and I'll show you a clip from this and it'll give you the idea of how this system works. Now let's see how we read the VSWR. I'm operating on the 40 meter band. I've got 10 watts power output, and if you look at the SWR scale where the two needles cross, it indicates we've got a VSWR of about 2.3 to 1. So you see how the VSWR can be read even when we're reading power output and reflected power. In other words, you've got the three readings, and VSWR becomes very obvious once you understand that where the needles cross is where the VSWR is. I've set the transceiver up 10 watts output on 15 meters, which is a real no-no band for the half-size G5RV I'm using. And without the antenna messaging unit switched in, you'll see I've got a very high SWR. It's about 4/4:1, which is not very good. I'm now going to switch the unit into circuit, and now you'll see that I've got a very good VSWR, or an apparent VSWR, because it hasn't changed the VSWR on the coax lead, but the transceiver sees it as a nice VSWR and delivers full power. And if I move this control a bit, you'll see that we can zero it into a very good VSWR, and it's a pretty good demonstration really of how this antenna matcher will match even a pretty awful VSWR. What you will notice is that I've had actually to move the coil inductance from 15 meters to the next band up, and it does mention in the instructions that although this inductor calibration on the front panel shows the bands, sometimes you need to go up to the band above or band below if you're dealing with extreme reactances. Now I've set the radio up to the foam part of 80 meters. My half size 5RV just won't match it. I'll just press the ECU button in here and find it. There we are. And you can hear it it bleeps. It refuses to match on 80 meters. That's using the internal antenna tuner or matcher on the 710. It will not match half size 5RV on 80 meters, which is not surprising. Let me just show you the VSWR on the meter. Terrible VSWR. It's almost off the scale. It's horrible. No matter, or no, not surprising that the 710 won't match it. It's terrible. Right, I've now resonated the matching units on 80 meters. This is with the matching unit out of circuit. Terrible VSWR. Now I'm just going to switch it into circuit, and now you see we've got a very good match. A very good match. If I move this knob about a bit, you'll see it rise up a bit. There we are. You see, basically we can get a good match. I can actually operate my FT710 on the 80 meter band. Now I have tried it, and I have had a couple of QSOs on 80 meters. Not the best signal reports, because Obviously a half-size 5RV doesn't radiate very well at all on 80 metres, but at least I can work on 80 metres. Now the ultimate test, can I match the half-size 5RV on the 160 metre band? I would say no, that's not going to be possible, but let's give it a try. I've now set the transceiver to the bottom of the 160 metre band, 1.840, which is where quite a bit of CW activity takes place, but this is the extreme. Will this matching unit match the FT710 on 160 metres? Let me just prove that it won't do, the internal matching unit won't do it. Right, let's put the camera down a bit. I press the AT button. You can, I hope you can hear it. It just won't match it. Not surprising. Why would you even expect to match a half-size 5RV on 160 metres with an internal matching unit? So we've now got the matching unit, well, it's in circuit anyway, but at the moment the matching unit is bypassed, and look at the terrible VSWR we've got on 160 metres. That is absolutely appalling. It's almost off the scale. Now let me press this button in here to switch it into circuit, and look at that, we've got a match. The matching unit has actually matched a half-size V onto 160 metres. Just let me show there's no trickery by detuning it. Now you can see that, can't you? That's amazing. The AT300 has matched a half-size 5RV on the 160 metre band. Can you believe it? Well, I have to admit that I was certainly amazed at the capability in matching some very difficult situations. 15 metres on the G5RV, okay, well it was about 4 to 1. But when it comes to 80 metres, and then it comes to 160 metres, that seems incredible really. Now I have to admit I haven't had a contact on 160 metres. I guess if I was working somebody close by, 2 or 3 miles away, they'd probably hear me, and I'd be able to have a QSO. 80 metres, well, I worked 1 or 2 G RBN beacons, I woke them up with CW and had a couple of QSOs, so I know it works on 80 metres. Even then it's not that efficient, but it doesn't mean to say that you can actually match the antenna, and if need be you could have a QSO if you were in range of the station you're trying to work. It's very impressive. Let me show you now how the PEP meter works. At the moment it's switched out of circuit, it's on average. So 1, 2, 3, 4, 5, 5, 4, 3, 2, 1. Hello test, 1, 2, 3, 4, 5, 4, 4, 4, 4. Now what I'll do is I'll switch it into circuit. Hello test, 1, 2, 3, 4, 5, 4, 4, 4, 4. 1, 2, 3, 4, 5, 4, 4, 4. So you see how the PEP meter gives certain benefits in terms of reading power, and although I've got a perfect match on here, the average only works on the actual power meter. It doesn't affect the VSWR meter. That works normally and moves around very quickly, but when you've got the PEP selected, the left hand meter, the power meter, 1, 2, 3, 4, 5, 4, 4, 4, 4, 4 gives you not exact PEP, but it gives you a pretty good indication. Take it out of circuit now. Hello test, 1, 2, 3, 4, 5, 4, 4, 4, 4, 4, 4, 4. That's out of circuit, 4, 4. And let's switch it in circuit. 4, 4, 4, 1, 2, 3, 4, 5, 4, 4, 4. Now let me finally explain the way this matching unit can be integrated into your station. There's 3 separate parts to it. You've got the VSWR power meter, you've got the matching circuit, and you've got the antenna switch. You've got a choice of 2 antennas, and one of those antennas can be an end-fed wire. But if you do use an end-fed wire, you do need to make sure you put a counterpoise on the earth side of the matching unit. I haven't got an end-fed wire fixed up at the moment, so I couldn't check it out, but I'm sure it works. So what can you do? Well, if the matching unit is switched out of circuit, then the power meter still works as a normal VSWR meter, and the antenna selector also works as a two-way antenna selector. So without a circuit, with the matching unit out of circuit, you've got a power meter and you've got an antenna switch. Switch it into circuit and you've also got a matching unit. Now the good thing about that is, let's just suppose that your antenna is pretty good on 40 meters through to 10 meters. You don't need a matching unit. So you switch it out of circuit. On 80 meters, for whatever reason, you need a match. So you switch it in on 80 meters, you adjust the VSWR, you adjust the matching unit for a good VSWR on 80 meters. And then it means to say that if you're on 40 meters through to 10 meters, you just switch the unit out of circuit. You've still got your power meter, you've still got your antenna switch. When you go to 80 meters, you just press the button, bring the matching unit into circuit, and you've got a good match on whatever antenna you're using on 80 meters. So you see, it's quite a versatile unit. So in summary, I was very impressed. It's nicely made, it's got a nice finish to it, it's a nice cabinet, it's well built inside, it looks the part. The tuning knobs work extremely well, they're very smooth, they're very easy to use, they're not sort of twitchy or anything like that at all. And everything seems to work okay. The power meter is good, it gives you good indication of peak power. It's not a perfect peak power, but no analog meter will give you perfect peak power, but at least it gives you some indication. And altogether it's a nice unit to have. It's very versatile and it has a lot of applications. And as I said at the outset, MFJ used to be the dominant power in antenna matching units, but now with the closure of the factory, this item certainly seems to fit the part. It's nicely made, it does the job, it works extremely well. Can't be fairer than that. But I was really surprised. I was surprised how it has the capability of matching a wide range of impedances, far wider than I expected. And it dawned on me after I've been using it for a little while, of course, that this ability to switch the matching unit in and out of circuit is very useful. It can be kept in the station and only switched in when you need it. So altogether, very impressed with it. It's a nice unit. So as usual, thank you for watching this video. Thank you for your support on this channel. It's much appreciated. Don't forget to press the subscribe button. All it means to say is that it alerts you when there's another video coming up. But I do really thank you for your support on this channel. It's really encouraging. And I personally put a lot of work into videos on this channel. And I hope that you enjoy the end product. In the meantime, you take care, enjoy your ham radio. Don't forget Waters and Stanton. We've got a wide range of products, transceivers, antennas, bits and pieces. Go on our website, check it out. In the meantime, you take care, and as usual, I look forward to seeing you in the next video. Bye for now.